Why is convergence critical for circuit simulation accuracy? Imagine trying to find the right piece to complete a puzzle. If the pieces don't fit together properly, the picture stays incomplete. That's similar to what happens in circuit simulation when convergence isn't achieved. When engineers use circuit simulation software, they're relying on iterative calculations to find the right voltages and currents at every point in the circuit. These calculations are like trying different puzzle pieces until everything fits perfectly. Without convergence, the software can't be sure it has found the correct solution. It's like trying to balance a scale that keeps tipping over. Achieving convergence means the simulation has settled on a stable answer that accurately reflects how the real circuit behaves. This is essential because circuit models include complex nonlinear components like transistors and diodes. These parts don't follow simple rules, so the software must solve tricky equations to get the right answer. If the solver doesn't converge, the results can be wrong or incomplete, leading to poor decisions in designing or troubleshooting circuits. Convergence is also important because it helps avoid errors caused by numerical instability. Sometimes circuit equations are sensitive, especially in circuits like oscillators or switched power supplies. Small errors can cause big deviations in predicted behavior. To prevent this, simulation tools use techniques such as adjusting tolerances or adding tiny parasitic elements to stabilize the calculations. This makes sure the software doesn't jump to false solutions or get stuck. Another key point is that setting the right convergence criteria is a balancing act. Making the criteria too strict can slow down the simulation, taking more time and resources. But if they are too loose, the results might be inaccurate. Engineers need to find the right middle ground to get reliable results quickly. They can do this by tweaking the tolerances or using advanced solver options like auto-convergence features. In practical terms, understanding how convergence works helps engineers troubleshoot simulation issues. If a simulation fails to converge, it often points to problems in the circuit model or setup. Adjusting component values, adding small resistors or capacitors, or changing solver settings can often fix the problem. This skill is a vital part of professional development because it improves the reliability of the entire design process. When engineers master convergence, they can trust their simulation results more, making better decisions and saving time in development. In the end, convergence is what makes the difference between a simulation that's just a rough estimate and one that truly reflects how a circuit will perform in real life. Without it, the results are unreliable, and that can lead to costly mistakes. That's why understanding and controlling convergence is a fundamental part of using circuit simulation software effectively.